Hello, Year 8. This is Mr. Radmel, and this is the space topic Lesson 4. And for Lesson 4, we're going to talk about orbits. So, a very, very important physical process for our universe, the way in which objects interact with each other, especially for our solar system, in fact. So, your driving question: which orbit is best for spying? And for a starter question, can you tell me how long does it take the moon to make one complete orbit of the Earth? Is it 27 minutes, hours, days, or months? So pause the video. Okay, so a complete orbit of the Earth, the moon ends up back where it started from 27 days later. Okay, so let's just talk about that in a bit more detail. Let's define the keyword orbit. So an orbit is a path of a smaller object. It's not always smaller, bigger, but we're going to just talk about those examples for this lesson. So it's a path of a smaller object around a larger object. And the reason why it's going around that larger object is because it's influenced by the force of gravity, which is pulling it towards it. Okay, so that's our definition of orbit. And another keyword, important keyword for this lesson, the orbital period. This is the time taken for an object to complete a whole orbit of the larger object. So an example of this would be the orbital period of the Earth around the Sun. Of course, we all know that's 365 days or one complete year. Okay, so we're going to firstly just think about those two keywords, two important key ideas for the lesson. Which of these statements is false? Which is a porcupine, which is East London slang for lie? Pause the video and decide A, B, C, D. Okay, so it was in fact the orbital period is the time taken for one complete orbit, not two, just one. Okay, right. So let's talk about two specific and important orbits around the Earth that satellites take. Now, satellites have completely transformed the way that we live in terms of their ability to send information from one place to another place. And we're going to talk about two specific types of orbits that satellites use to do this and different uses for them. Okay, so the first orbit we're going to talk about, a type of orbit around the Earth, is called a geostationary orbit. Now, if a satellite is in a geostationary orbit, it's taking 24 hours to complete that orbit. Now, that is the same amount of time it takes for the Earth to spin once on its axis. So that means that a satellite in geostationary orbits spins at the same rate as the Earth. So as you can see from the animation here, it always stays above the same point on the Earth, which makes it very useful for communications because it's always above the same place. You can always bounce signals from one place to another. You know where it's going to be. You can see the yellow patch on the Earth's surface shown here is the area in which this satellite is covering, is able to interact with. Now, a geostationary orbit is usually about 36,000 kilometers above us. It's really far away. Okay, so that is our geostationary orbit. Because the satellite in geostationary orbits would is directly above us, it appears stationary. That's what geostationary stands for. The satellite is always above us. Okay, and so it can always pick up a signal whenever you need it to. So useful communications, television, internet, etc. And other satellite television and weather observation as well, like looking at a specific area of the planet, is very useful in a geostationary orbit, or satellites using the geostationary orbits. So that's one type of orbit that a satellite can be using. Okay, now another type of orbit that a satellite can use is a polar orbit. Now, the geostationary orbits, just go back to that, the geostationary orbits goes along what we call the equator. So the middle bit of the Earth, which kind of like goes straight through the Americas, southern part of Africa, or tip bit of Australia. Okay, polar orbits does it at 90 degrees, so it goes over the North Pole and South Pole at 90 degrees to the equator. Polar orbit is one in which a satellite passes above or nearly above both poles, 90 degrees to the equator. Okay, now here's the important difference here. Every time it does an orbit, it does a satellite in polar orbit does it over a different part of the planet. So a satellite in a polar orbit gets to see the whole planet within a few days, which makes it's just different to geostationary, which only sees one bit of the planet only. So that makes a polar orbit very useful for spying from the driving question, which we here is called reconnaissance. So polar orbit moves much faster than a geostationary orbit. It only takes 90 minutes. That's the minimum. That's the round about the orbital period of a polar orbit. And as you can see from the animation, look, every time it goes round one orbit, it sweeps over a different part of the Earth. So if you wanted to know what was going on in India, you only have to wait probably like a few hours before your spy satellite was going over India, for example. So it's moving much faster than the geostationary orbit. And also it's much lower. It's much lower down in the sky. It's only 200 kilometers to about 1,000 kilometers above the surface of the Earth. Okay, so two types of orbits that man-made satellites can orbit around the Earth. We've got geostationary and we've got polar. And because of the different orbits, the different orbits lend themselves to different uses. Geostationary mainly being for communications and polar being for spying. There they are there, look. Okay, and as you can see there, look, you can see the yellow spots from the geostationary orbit always above the Americas in this case, and the yellow band from the polar orbit gets to see pretty much everything within at least a few days. So let's try and have a think about how we can distinguish between these two orbits, the polar orbit and the geostationary orbits. So just write 1 to 9, and does the statement apply to the polar orbit, the geostationary orbit, or does it apply to both of them? 1 to 9, and just put P for polar or G for geostationary to give you an idea of how these two orbits are different and used differently. Pause the video and have a go at that. Okay, so let's summarize these two orbits then. So orbital period exactly matches Earth's rotation. Well, that's the geostationary orbit. The orbit height is greater. That again is geostationary. It's much further out. The orbital period is only a few hours. That's the polar orbits. So the polar orbit is whizzing around much faster than the geostationary orbit. The satellite is in continuous contact with one area. It only ever looks over one area of the Earth. Well, that's geostationary. Gives access to every point on the Earth's surface every day. That's polar. You need a much lower signal strength. That's going to be polar because the polar orbit's much closer. Application includes surveillance, which is another word for spying. That's polar as well. Going much slower, that's a geostationary, 24 hours to go round once, remember, same as the Earth spinning, and then gives access to every point on the Earth's surface every day. That's polar. Okay. So last up, let's get an idea of the physics behind an orbit and have a think about how it works. Well, Sir Isaac Newton, devised this thought experiment to help us understand what an orbit is. He had a thought experiment where you had a very, very, very tall mountain, very, very tall, and at the top of that tall mountain you put a cannon, and that cannon fired a cannonball from the very top. Now, as you can see there, the cannonball just kind of like gets pulled down by the force of gravity, of Earth's gravity, and down it goes. Now, what if you just had an insanely tall mountain and a really powerful cannonball, and you got yourself into a situation where the cannonball was fired, as you can see there, look, so it actually eventually ends up falling all the way around the Earth. Now, this is an orbit. This is what an orbiting object does. It falls around the larger object. And Newton's thought experiment was very useful in us understanding why orbits happen using the idea of gravity. Okay, so that's Newton's cannonball thought experiment explaining orbits. So now, can you pause the video and can you work through these questions? For describe, can you define those two key words for me? For explain, can you explain the two types of orbits that we've talked about, geostationary and polar, what they are? And then for use, can you explain why geostationary is used for communication and why a polar orbit is used for surveillance, reconnaissance, spying? And then for combine, can you combine in ideas of gravity and use Newton's cannon's thought experiment to explain why things orbit other things? Using that idea. Pause the video and have a go at that, please. Sentence starters in red. Okay, so let's go through some of these ideas. So definition of the word orbit is the path of a smaller object around a larger object under the influence of gravity. Now, the meaning of the word orbital period, okay, it's the time taken for one complete orbit. So remember, the orbital period of the Earth around the Sun, for example, is a year, 365 days. A geostationary orbit, that is an orbit where a satellite follows the equator and has an orbital period of 24 hours. So it takes 24 hours to complete it because it's obviously matching the rotation of the Earth, which takes 24 hours to rotate as well. Okay, explain what a polar orbit is. Polar orbit is when a satellite orbits at 90 degrees to the equator, and it only has an orbital period of about 90 minutes to a few hours, and it's also much lower in height, much closer to the Earth's surface. So can we link those explanations? Can we use those explanations and apply them to the uses? So explain why satellite and geostationary orbit is used for communications. Well, a geostationary orbit means the satellite is always above the same place, okay, because it's got the same orbital period as the Earth's rotation. So that means that it can always bounce signals, reflect signals from one place to another, from the TV company to your television, for example. That satellite is always up there for us to use. Right, explain why satellite polar orbit is used for spying. Well, a polar orbit has a much shorter orbital period and is much faster, and so can cover, because it's every time it orbits, it covers a different part of the Earth's surface. It can cover the Earth within a day or a few days. It can see everything that's going on the planets, making it much more useful for spying. So for Newton's cannons, Newton had a thought experiment that the cannon top of a tall mountain, and you fire off that cannonball, and if it's high enough and powerful enough, eventually the cannonball will fall all the way around the Earth. And that's what things in orbit are doing. They are falling around larger objects due to the force of gravity. Okay, so let's have a think. Where are we in terms of orbits? Can we copy and complete the plenary statement, please? For describe, can you define the orbit and orbital period? For explain, can you explain what geostationary and polar orbits are? For use, can you explain why geostationary and polar orbits are suitable for their jobs, for communications, and for spying? And for combine, can you draw a diagram and explain how Newton's cannon's thought experiment explains why objects orbit each other? Okay, and don't forget, every lesson comes with a Show My Homework quiz, 10 question multiple choice, and these results will be recorded. Thank you very much, Year 8s. Have a pleasant day.